All right, round two.
Okay.
Bed number 32. This is Nick
Winston.
Lunar Express. C6 power. Got the flashing blue light here. Okay, going in 5, 4, 3,
There we go.
2, 1.
Begin.
We have to do the rest of them high powers, and then the range is going to be close.
Looks like we got recovery. I'm calling it good. Going on to pad number 33.
Ladies and germs, welcome back. I've got a new project for all you fine folk out there. I have recently gotten back into model rocketry and gotten back into it with a big kick. Anyways, I thought I would go ahead and take my crack at it back again with model rocketry, and I wanted to do it in a big way. Namely, I wanted to throw electronics at it, and I mean a metric shit ton of electronics at it. So, we're starting small, but we're going to expand out. This is the Avionics board for my model rocket. It looks like shit, but it's gonna grow into something much grander as time progresses. By avionics, I mean either control systems or some kind of data logging and flight logging sensor majigamy thing. This is basically just a data logger for temperature and pressure as it goes up. It's finally complete, thank God. Holy crap. Geez, after so much work this week, I've finally got the final board made. With all this big mess of wires, I'm probably going to do in a Mark II, just make it all on one PCB. But anyways, to point out the individual parts, there's that little board right there with the LED glowing, if you can see it. That's a Arduino Mini Pro running at 8 megahertz at 3.3 volts. And then stacked on top of that is the power distribution board. It's just a little matrix PCB. Excuse me. That's the power distribution board. Right there, the little black thing is the IR receiver. And next to it, the little clear thing is the blue LED. Both to receive the start command and signal back to the user that, hey, we're going, good for go. There's a JST LiPo battery connection. This little 6-pin header is for the BMP 180 pressure temperature sensor. And right there is the FRAM. I'm using that as the main storage medium. It's a FM25V10 by Cypress Semiconductor. And it's got 1 megabit of memory right now, so that gives me about 128 kilobytes of program space. Or not program space, storage logging space. Excuse me. Anyways, went ahead and already loaded up a couple of the programs on there to test it. I've got it hooked up right now to my Arduino Uno through a level converter for both downloading programs as well as talking to it over serial. And so I went ahead and just tested by downloading the already existing log on it that I had written to earlier. Excuse me. Needless to say, I'm using TerraTerm is my terminal program, and it's got a nice feature where I can just go ahead and automatically, while it's printing out all the terminal data, it can just auto dump it to a file. So final avionics log.csv. I went ahead in my downloader program, have it automatically generate commas between values, so that way I can just load it up into Excel or OpenOffice or something and play with that data as I see fit. So for example, I went ahead and downloading a Avionics FRAM log. I already completed this, but FRAM initialization, okay. And the first value is the absolute pressure. Of course, all of this is being spat out as hexadecimal, but that's the absolute pressure in pascals.
Second number, because it's all comma delimited. Second number is absolute temperature in centikelvin. So it's basically Kelvin times 100. So that way you can get rid of the decimal point. So instead of, say, 300 Kelvin, it's going to be, let's see, yeah, 30,000 centikelvin, if that makes any sense. So that way that just gets me, allows me to get rid of the decimal point and still have precision while saving on space, like actual data space. After that is all this uninitialized FFFFF. That's for later data I want to store. I want to store accelerometer, magnetometer, and gyroscope data in flight later on. So all that's just uninitialized for a future version. Just so I can go ahead and say, all right, well, I want to do this amount of samples in total, and it's going to require X amount of bytes per sample, so I want to get used to how much storage space it uses. And then the beef hexadecimal is my magic number to just signal end of line, so dead beef, but in this case it's just beef, so that way I could save on space. Anyways, so yeah, that's all spat out to a CSV file, and then I can play around with it in Excel and whatnot later. So that's that. I'm going to try to cram it or load up the proper logging program, and then stuff it all into this here rocket. And the FRAM as well as the LiPo battery are going in the nose cone, and then all those wires just come down from there, and it's a really tight fit. In my Mark II of this rocket in the future, I'm going to either lengthen this payload tube or get a wider body tube or something. So, but this is what I had to work with, so alas. But, oh yeah, the LiPo battery itself is a 3.7 volt, 110 milliamp hours, and it's really small, but it for the amount of power that I'm drawing off this entire logger, it's gonna work over like tens of flights, if not closer to 100 flights, without needing a recharge. Because the Mini Pro, it's got its own 3.3 volt regulator on it, so it's got a really low dropout regulator, so it's just going to take 3.7, drop it down to about 3.3 for all the rest of the electronics. So, anyways, thank you for watching. I'm going to post more videos about this and whatnot in the future.
So I thought I'd give an actual, more interactive demo of how my Avionics data logger actually functions for my model rocket. I went ahead and uploaded the actual logging sketch. So I have two sketches. One of them is the downloading sketch, and the other one is the actual logging sketch. So I aimed to have it sample about once every 25 milliseconds for an upwards of 80 seconds total. So that gives me about 3,200 samples, and I figured that would need a fairly beefy FRAM or storage device to work with it. So anyways, I went ahead and uploaded the sketch, and I'm going to demonstrate it to you. It's a this one has the serial debugging enabled. Normally I just have it disabled, but I'm going to go ahead and plug it in now to my desktop, and boom. So it's already flashing blue, and that's just the startup of the program. Epilepsy warning, sorry about that. The blue flashing just indicates that it's on standby and ready to rock and roll. I've got the actual remote that I used to initialize it earlier. So yeah, I'll show you the terminal, but if I go ahead and, because I programmed it for the OK button, if I click OK, boom, it goes solid, and then it starts recording. So Let's go ahead and plug it back in and see what it's spitting out on the serial terminal. Anyways, let's go ahead. COM3, 38,400 baud, and then resets. All right. Let's see if y'all can see that. There we go. Beginning model rocket avionics, and initializes both the BMP 180 sensor, the FRAM, and the IR receiver, awaiting go no go signal. All these numbers here are time stamped in units of microseconds, and so 8 microseconds to, or 2 microseconds to initialize FRAM. So anyways, it's awaiting the go no go, which is basically the remote, IR remote, and it's still flashing right now. If I go ahead and hit OK on the remote to start it, clearing FRAM, so it's just wiping off the previous log, and then it's spitting out all the samples right there. Yeah, it takes a while because, I mean, it's supposed to continue for a full 80 seconds, so I'm going to spare you that and go ahead and just cut it. So it spits out the sampled time in microseconds, and as well as the sample number. It tells the OK. So it grabs the data because the BMP 180, it takes about 7.5 milliseconds max to, at worst, that is, grab the data from it with a normal standard resolution. It preps the data by splitting the BMP 180 returns a double, and so I'm splitting that into 4 bytes. So that's the prepping the data, then writing to FRAM. So I'm writing both the pressure data and the temperature data. And then it waits, or is supposed to wait. Gonna have to fix that. It waits until until about 25 milliseconds have passed. Supposed to do that. I think I have a bug in my code. Anyways. So that's what it does, and then it just continues to the next sample, and it continues until 3,200 samples have been written, and then it's good to go. So anyways, that's it. I'm going to have to do some work on the code, because this is still beta. This is nowhere near final, so I'm going to have to double check that. But anyways, thanks for watching, and see you later.